Simulation models are often used to analyze a decision under risky conditions where the probability of a change in one or more factors of the model is known with certainty. The quantity demand for the product in the next month or the change in the stock price. The random variable is the factor that not known with certainty. The change in the random variable is described by a probability distribution. Later, we will have an example to apply how to find the random variable. This type of simulation is called the Monte Carlo method, the roulette wheel method. The configuration generates random or uncertain events. And we will move to the second part, that is how to set up random variables. To simulate one model, we have to generate the value for some random variables. And if we have the continuous random variables, for example, like the quantity of the product of some project is fluctuate between 65 product to 73. It means that it continue 65 to 67. So we will use this function called rand function. We will input the value into it, and if the variable is discrete, it means it get a limited number of value. We will use this function. And we have four main types of probability distribution. The first one is uniform distribution. This means that the random values in the interval have equal probability. The next one is normal distribution. One random value with the highest probability value above or below the mean have the same probability. And the next one is binomial distribution. We have only two values and outcomes are independent. Next one is log normal distribution. The variables can increase indefinitely but cannot be less than 0. The log of variable has a normal distribution too, and we also have many other probability distribution, but we only focus on four main type. The next one is about the cumulative distribution function. This function is in the probability that the value d is less than x, or we can know that the fx equal to probability. We can write like this too. For example, the quantity demanded value d, then the cumulative distribution will help determine the continuous random variables. And the next one is we will apply the simulation to Excel, and it will present by proof.
Hello, teacher and everyone. Now I will continue with modeling with normal basis, and we will move to a case study. In this case study, the airport is considering about the financial ability to ask a new product branch, and startup cost for new aircraft is about $150 million. And in this demand forecast, the company is predicting about 10 units for per year, and this will happen in 4 years. And the price is for one product is 35 million. Fixed cost is about 15 million for a year, and variable cost is 7 75% of total sales. And you know, equipment division is about 10 million for a year. And this will return in four years, and value remaining of this equipment at the end of year is 0. Cost of capital is 10%, and the corporate tax is 34%. And I will show this in Excel. And you can see this in this product demand for 10 units for 4 years, and we can get a sale from the product demand is about $350,000 million. Because the selling price for each product is about 35 million, and the fixed cost is about 15 million. Then from the sale, we can get a variable cost is about 75% of total sale. You can see this. We can get a number if product demand is 10, and we can get variable cost from the sale. Is the number is 262,500 million dollars. The depreciation is stable for each year. We can see that in this case study. From that, we can easily get the earning before taxes, and we know the tax is about 34% of the sales. So we can easily also get the number. And you know, this is also the thing that we can get when the number is stable for each year. And from this, we can get the net cash flow. The net cash flow is the earning after tax plus depreciation. Because in the first year, the initial cost is about $150 million. So this is a negative number from the net cash flow, and we can easily get a net present value. The net present value is the number of the cost of capital, and we can use the NBV function, which we have learned a lot of in many corporate finance. But the problem here is should Airbus take on this project, and if the quantity demands of these aircraft is not certain as assumed, we can get the following values of 8, 9, 10, 11, or 12 products. The probability of each value occurring equal, and from this I will assess the project risk to get you know more about should Airbus take on this project. And in specifically the average value, and also show the average value of expected value of NBV, and the probabilities that the NBV is negative. Because in this case, we assume that the number of this product is not constant each year like that. We will get the number of products, it may be 8, 9, or 10, 11 for each year, and we don't know exactly what the product is meant for each year. In this case, we will use the function which Nguyen has mentioned in the reverse bar. The function here, we will use that the number here is discussed, then the product is meant it will happen between 8 and 12. So in this number, we will use that the A.
So why we use this formula? Can you explain more for us?
We use this.
Yes.
We use this formula between that we don't know exactly what the values of this product is meant will happen, and it's also the result from the continuous modeling, and which Yin has mentioned in the reverse part from you. And so we can, if we use this function, we can easily get the many many value that we cannot expect it. And from this we can try a lot of tests which can give you more about the value to help you manage the product demand. From this you can see that the robust demand will happen between 8 and 12, which I read it will create a new value for you to see this. From this you can see the NBV will trend from each year, and you can see that's a lot of result will happen for you. But the problem here is we want to test more, and we want to get a more result from the product demand. So what happens if we try to set about 1,000 stamp to get the exact value? From this, we will use the data table from the spreadsheet, and I will show you how to use data table. The data table in spreadsheet is which we try a test from the number of steps we want to trial. For example, in this case, I want to test about 1,000 times, and we will use the table in data table in the Excel. We will use the series to fill up to 1,000 from 1 to 1,000. You can see it, I fill up a number in order to get you really know more about the total of stats I want to try. And the NBV here we will get the result from the reverse system.
Sorry, I can't see your screen.
Sorry, I have wrong. Can you see it now?
Okay.
This I will do it again. This NBV we will take it from the reverse spread like this. You see, we will get the NBV from the reverse spread, and now we will try to do this 1,000 times. From this, we will use the data table from spreadsheet, and we will use this here. We move to the what if analysis, and we use the data table. Sorry, we will check it 1,000 times in this case. And we move to what if analysis data table here. In this column is in boost cell, we choose randomly a column we want to try like this. And you see, from this I can get a 1000 stamp of a NBV value I want to test try. And this is a value of 1000 NBV value I 1000 test. From this we can easily guess the means. In here we review the average function. We will have the mean of NBV values here is the total average of the 1000 steps. And from this mean we can get the standard deviation. We also can get the standard deviation of the NB from the 1000 stamp of the NBV. And in this case, we want to know more about what happens if the NBV, what the probabilities of the NBV if the NBV is negative. And from this, we assume that the NBV is negative, and the NBV is 0. So we can calculate the z-score. The z-score here, we will use the function. The z-score here, we will assume that the NBV is 0. So we will take this to minus the means. Then we divide to the standard deviation, so we can get the z-score. And from the z-score, we can know that the probabilities of the NBV when the NBV is negative. We will use the norm list function to get the NBV from the z-score. From this, we can see that if the NBV is negative, we can easily guess the probability is about 18%. So we can train the NBV to the value we want to test and try, and we want to get the information about the probabilities. For example, we move to the means. You can see that the means is about 12,000. So maybe the NBV is 12,000. You can see that the probability is about 49%. It's totally approximately with the mean. So from this, we can get the important notes, like increase the number of trials to get the better expectation values. But there is still an error between the mean simulation values and expectation values. Simulation value can provide useful information from distribution of the resulting values. And this is very valuable information, and this result cannot be obtained from simple analysis single, or even in analyzing the risk of right, including up and down price. The simulation results are quite sensitive according to the assuming input factor, which I have shown you now, which you can easily see this in the Excel. Because if we train the product demand from just another input of the product demand, we will get another result. And the next part is the modeling with the risk bond. And I will introduce you about Ristobon, but I cannot give you an example about Ristobon because I cannot install it. In the resist setting, we can use a Ristobon or Rist really simplify the process of setting up random variables and gathering statistical outputs. Because you know that in the normal resist, we just can use a small step. But if we want to set about 10,000 times or 100,000 times, it's very hard for the it's very hard for the resist, but easily to test if we use the Ristobon. And for models with more complex distribution or more iteration, the resist simulation can become impractical. The async program has a different number of reprogram functions that will generate a random variable fully automatically. And we can see that Ristobon with more tests, the reliability of simulation result will be higher. From a statistical point of view, real confidence interval based on our result. For example, if we have 95% of confidence that the achievement of NVV will be within 1.96 standard deviation of predict mean. In this case, the predict mean standard deviation will be equal to the theoretical standard deviation divided by the square root of the number trial. You can see this in picture. The more tests we do, we can get the exact value we want to get. And to get more about this, the Ngọc Nhiên will show you the example about the real case in the world.
So here is the case study. To apply, we have a case study to apply the random variables into the real world and also simulate the NPV. And here is some figure, some important figure that we need to calculate in the case study. First one, we are given that the cost of the machine of this project is 18 billion, and we also have the net working capital is 2 billion, and this project will depreciate in 8 years. Later, we will use this figure to calculate the depreciation. And we also given that the variable cost is 3,000 per product, and the sale price is 12,000 per product. The fixed cost is 1 billion, and it is said to be increased 8% per year into year 5. And the quantity is 700,000 product in 5 years. The tax is 25%, and it is said that in the end of the year 5, the machine will be sold at 6 billion. And we also study that 6 billion here is called the salvage value. And so that we can use it to calculate the after-tax salvage value. And we also given that the project will borrow the bank 30% with the interest rate is 6%, and the 70% left is from equity with the cost is 16%. And the requirement require us to build the cash flow and also calculate the NPV in IRR. And it also say that the quantity is not fixed at 700,000 product per year, but it distribute between 650,000 to 730,000 product. And it is we need to simulate the NPV and to calculate the average NPV, also the max, the mean, and also calculate the probability to have the NPV negative. So here I have summarized all the figures that we need to calculate. And here's the variable that we need to calculate so that we can have the cash flow. So first we will fill in the blank some number. First we need the quantity is 700,000 3,000 products per year in 8 years. And we also have the sale here is we will take the sale price is 12,000 multiply with the quantity. We have 8.4 billion. And the variable cost is 3,000 per product. We take 3,000 multiply with the quantity in 5 year too. And next is the fixed cost is 1 billion. And it is said to be increased 8% per year to year 5. Okay. This multiply with 1.0408. And it will be increased in 5 years only. And the depreciation is also said that it will depreciate in 5 years. So and because the requirement tell us to use the sum of digit method, this method will be calculated. We need to sum the total year we have from year 1 to year 8. That means we have total 86 years. So in the first year, we have to depreciate 8 years. So we take 8 divided by the total year and multiply with the cost of machine is 18 billion. Next, for year 2, we take 7 divided by 36, multiply with 18 billion. 6 divided by 36, multiply with 18 billion. 5 divided by 36. And last year is 4. And because we only focus on the first 5 years of the projection, so here. So we have the total depreciation is 15 billion. And next, the earning before tax, we will take the sale divide minus all of the cost. And the tax is 25%. So we take the earning before tax, multiply with the tax. And then for the net income, we take the earning before tax minus the tax. And to calculate the operating cash flow, we add back the depreciation into the net income. For the net investment, or we can also call it the cost of machine, as I have said, that the money you have to pay in the initial, so it is a negative number. It's minus 2 billion. The net working capital is 2 billion. And in the end of year 5, you will take the net working capital back. So and the next one is the after-tax salvage value. To calculate it, we need to calculate the book value here. The formula of the book value here is equal to the initial cost is 18 billion minus the total depreciation. So we have 3 billion. And the after-tax salvage value, we will take the salvage value here. The money that we will receive if we sell the machine is 6 billion minus the tax, multiply with the salvage value minus the book value. we have 5.25 billion. And to calculate the cash flow, we will sum the operating cash flow with all these costs. Here, we have all. So, and the next requirement tell us we have just built the cash flow of the project, and the next requirement tell us to calculate the NPV and IRR. So to calculate it, we need to calculate the weighted average cost of capital first, or you can know at the rate of the cash flow. Here is the formula. You take the percentage of the equity divided by the total percentage of equity in debt, which is 1, so I will skip it. Multiply the cost of equity plus debt, and multiply with 1 minus tax. We have 12.55%. To calculate NPV, we use NPV function. First, we need to input the rate and the cash flow, and we plus this because this is a negative, so we have to put it out. Yeah, so we have our net present value here, and it's the same for the IRR. 13.47. The final requirement say that the quantity is not fixed at 700,000. So we need to set up random variables from 650,000 to 730,000. Because it's a continuous value, so we will just simply use the rand from 65. We use the rand between, I'm not mistaken, from 65 to 73. Yeah. Who will randomly pick for you? This. And you take this, multiply with 10,000. It will randomly pick the value for you. And as a result, the NPV will be changed because the variable is randomly distributed. So too, we will use the data table to simulate the value of NPV. I also take 1,000 value of NPV too. And first, you need to input the value that you have calculated in here. Yeah, it will be the same that you have in here. Next, we use the data table. Yeah, and it will display random variables, random NPV for you as the random variable is changed. So to calculate the mean, we take all of this, and it's the same for the max and the mean. So we have the average. NPV is 287 million. The max value is 1.116 billion, and the minimum net present value is minus 500. It's approximately minus 600 million. And to calculate the probability that the NPV will be less than 0 or negative, we need to calculate the standard deviation. here. And for the Z, we use this formula. The value that you want to calculate minus the mean and divide with the standard deviation here. So we have Z is minus 0.98, and the probability we use the normal distribution function. So we have the probability for the NPV is negative is 18.85%. And you can, if you want to calculate another probability, you can change the value here. For example, you want to calculate the probability for NPV to be less than 500 million. And the probability will be 77.28. Yeah. And as we say, if you increase the value of the number of value NPV you take, you will minimize the change in the variable. You can see here it will change a little bit, but as you increase the number of value you take, the change will be minimized. And the case study is also the last part of our presentation. Thank you for your listening. And if you have any question, please ask me.
Okay. Can you ask the question? If I want to build the histogram of the NPV, the 1000 NPV I simulated. So I want to build the histogram chart for 1000 NPV. How I can do that in Excel? So you know the histogram chart is typically equivalent to the distribution, the density distribution. So if you want to see the histogram, you have to sort the NPV and arrange the NPV from the lowest to the highest. And with the frequency of these NPV, you have the histogram chart of the NPV. And can you show me how to do that in Excel?
Just give me a minute.
Yes.
Is this the right one, teacher?
Oh, I can see. Okay, this is not right. So, you know, when you want to see the structure of a 10,000 of a 1,000 MPV, you just simulate. You can use the histogram chart, and in Excel we have some useful tools to do that. Just follow my lead. First of all, you have to use the data analysis in Excel. Just open the data tab, and data analysis. Yes. And in data analysis, you have the histogram. Yes. So in input range, you just choose on the column of MPV 1,000 MPV. No, not the number, the column MPV. Yes, 1,000 MPV, and you just click OK. So this is the histogram. The histogram. With this, every MPV you have the frequency of these MPVs. So you need to use the chart, insert the chart for this histogram. So you choose on of this and insert chart. You can yes, you can use the bar chart. Just use the bar chart. No, not the histogram. Use the bar chart. But why you just change the axis? You can do it again. You switch row and column. Just switch row and column. Yes, switch. You switch the horizontal and the vertical of the chart to back the normal. Em chọn những cái ba chart bình thường thôi. Ở trên cái biểu đồ. Bấm cancel đi, cancel chỗ này đi, cancel chỗ này. Ở đó rồi, đó, chọn cái column đó, vậy thôi, đơn giản thôi. Được. Cho column. As you can see here, we have the histogram of MPV, and the value of MPV from the minimum value to the maximum value. With every value of MPV, we have the frequency of those value. And you can see this histogram. This is a histogram, and when you smooth this histogram, you have something like the density distribution function. Density distribution function, like the normal distribution with the bell curve. The bell curve, and it's the same. And it's noticeable that the middle of the histogram, the mean value is focused the most frequency, the most value of MPV in the mean value. And when you go to tell, is the value of the frequency will go down very low, and it look like density distribution function. So if you want to know what is the probability that MPV less than the number, the specific number, you just choose this number and you calculate on the column from the minus infinity to this number, and you have the probability of MPV will be which will less than this very particular number. Or you can use the formula just like the group form present us. Okay, thank you. So any question from class about simulation modeling? I think this technique is quite simple, and the key point is that you create the random number for your project, for your capital budgeting case, and when you create the random number, so the MPV will change accordingly to the random number, and we simulate 10, 1,000 or 10,000 or 1 million MPV. Every case we have one MPV. If we change the input, so the input is the random variable, the random number, that will change your goal, your objective goal, the MPV, and we collect 1,000 or maybe 1 million MPV and present those MPV in the histogram. So we can calculate or we can estimate the probability of the MPV which less than or greater than a specific number. So any question from other members of class? Okay, if you don't have any question, I will give you one more practical case to exercise, and this case is a very general, and I will test you that you can understand on of generating random number or simulation modeling. So the group 4 will do this task, and every member in the class will follow us, and you can practice with us. Okay, so I can share my screen for you to show my situation, my case. Hello, can you see my screen? Sorry, the connection failed. Okay, sorry you guys, my connection is failed, and I just reconnect back. So you can see my screen, and I will show you our example. So this is our example. So I will summarize some main information from this case. The company form is considering 4 projects with the cash flow as below. You can see we have 4 projects A, B, C, D, with very detailed in cash flow from year 0 to year 6. And the WACC of the 4 company is 10%. Just to calculate the NPV of every project here. And I want you guys to handle the question B in this situation. The group 4 will handle the question B in situation, which is give you some of information. Supposedly the company have enough budget to invest on 4 projects, and the financial expert of the company assume that project C is so risky. So the cash flow from project C from the year 3 have the uniform distribution. You know, the uniform distribution, exactly discrete uniform distribution. We have 2 types of the uniform distribution, the continuous uniform distribution and the discrete uniform distribution. In this chapter, you focus only on the uniform distribution, but the next section we generate the number following the normal distribution or the log normal distribution. So in the capital budgeting, we just use the discrete uniform distribution. And as you can see, the company have the discrete uniform distribution from 50 million to 90 million. So it can be 50, 60, 70, 80, and 90 with the same probability, with every outcome, 50, 60, 70, 80, 90, every outcome with same probability. And it is the uniform. The uniform distribution has the same probability of every outcome. So we have the 5 outcomes here, 50, 60, 70, 80, and 90. And each outcome have the same probability. In addition, due to the instability at the end of the project cycle, so there is an 80% probability that the cash flow from 3 projects ABD in the 2 final years reduce 20% value, to reduce 20% in value. And the question is, let's simulate the total NPV of the 4 projects and calculate the probability that make an NPV less than $200 million. Okay, so you need to copy the information about the cash flow of 4 projects here, and then you calculate the NPV of the 4 projects. And after that, you create a random number as the assumption of our situation, our case. and from that you can simulate the NPV. So just a 1000 NPV is enough for us in Excel to simulate 1000 NPV and calculate the probability that NPV less than $200 million. Okay, so let's do it. I give you 10 minutes for group 4 to prepare this practice, and you will present us your solution for this practice. Okay.
So we need to do all the A and B question.
Just question B. Just
question B. Okay.
Yes. The question A is about the optimization modeling. We don't need to handle that. Just question B about the simulation modeling.
Teacher,
I'm here.
Can I ask you what the function we use to calculate the 80% of the trees 80% the cash flow of the three project ABD in the last 2 years? What we use the function in the Excel?
Just the same function you created the random number in Excel, the random function. But just think deeply about how to arrange those functions to get your result. So 80%. So how you can create a random number with 80%, more than 80% or less than 80%, and the cash flow from 3 projects will be reduced 20% value in value. We keep using those function. The range and range between those function is enough for us to handle this situation. So in this chapter, we study 2 ways to create the random number with the range function and range between function. The range function will give you the random number, the continuously random number between 0 and 1. And the range between will give you the discrete random number from any interval you want to input the function. So if we want to create the random number from 9 to 20, just use the range between, and you just input the interval from 9 to 20, and this function will give you the random number from the 9 and 20, the integer number. Or you can combine the range function with the integer function. You have the same result. But it's no need to remember how to combine the range function with the integer function. Just use the range between. If you want to create or you want to generate the random number from the specific interval, use the range between. And the range and range between function will give you the uniform distribution and the uniform distribution. In the next chapter, in the next session, we study more function which generating the normal distribution number or the log normal distribution number, which apply in simulate the stock price and simulate the portfolio investment. Okay, group 4, can you solve my practice? Are you ready to present your solution? Group 4.
Please wait for a minute.
Okay. Các bạn còn lại trong lớp nhớ làm theo nha, thực hành nha, tại vì cái bài mô phỏng dự án này nó sẽ nằm trong cái bài kiểm tra giữa kỳ của chúng ta đó, cho nên là các bạn nãy giờ chúng ta có một vài cái bài thực hành này đó, thì nó cũng xoay quanh những cái bài thực hành đó thôi, về hoạch định ngân sách vốn thôi, tính toán dòng tiền và mô phỏng lại cái NPV. Chúng ta sử dụng hàm để chúng ta mô phỏng lại 1000 cái NPV. Chúng ta tính xác suất NPV nhỏ hơn một con số cụ thể nào đó, và cái kỹ năng này thì các bạn chỉ cần làm khoảng chừng vài bài thôi là các bạn cảm thấy nó quen thuộc rồi, để chúng ta có thể làm cái bài kiểm tra giữa kỳ. Và bài kiểm tra giữa kỳ của chúng ta chắc chắn sẽ có nội dung về mô phỏng ha. Nội dung kiểm tra giữa kỳ thì nó chỉ cần tập trung vào 3 nội dung thôi, là mô phỏng tối ưu với lại danh mục, với lại tính toán danh mục. Cho nên các bạn những cái bài thực hành trên lớp thì các bạn cố gắng làm theo nhóm thuyết trình để chúng ta xem coi là có cái vấn đề gì hay không. Nếu chúng ta thắc mắc cái gì đó thì chúng ta cứ hỏi trên lớp nha các bạn.
Teacher, we cannot calculate the 80% of the cash flow for the last 3 projects.
Okay. Actually, this is just a little bit a challenge for you to think more deeply about how to handle some assumption like this. So I will show you how to deal with this assumption. Okay. First of all, we copy the information about the cash flow up on the project, and just one. Okay. So firstly, we have to calculate the NPV of the 4 project. Okay, and we use the NPV function. The WACC is 10%.
Teacher, we can see your screen.
Oh, sorry. Okay. And then we recalculate on NPV of 4 projects. And we just sum all of this NPV. And this is our target, our goal, to simulate the total NPV of 4 projects. We don't need to simulate each project. We just simulate the total NPV of 4 projects. Okay. And the most important things in this situation is create the random number according to our assumption in this case. So we can see here the cash flow from project C from the year 3 have the uniform distribution at level 50, 60, 70, 80, and 90. So you easily create the random number for project C. And the value from 50 million to the 90 million, you use the range between function from 5 to 9 and multiply with 10, and you have a uniform distribution from the 50 to the 90. Okay, so just use the range between from 9 to from 5 to 9, and just use, and you multiply 10. So you have the random number with the uniform distribution, the 90, 60, 70, 80, and sorry, the 50, 60, 70, 80, and 90. It's easy to complete this assumption. And now we go to the second assumption in our situation. So due to the instability and due to the instability at the end of the project cycle, so there is 80% of the cash flow in the 2 final years may reduce 20% in value, and you have to create the random number for 80%. So 80% just the 0.8 in the rand function. You just use a little function here with the condition if. So I say if the rand number I create, the random number from 0 and 1 I create, more than, greater than 0.8. So the value, the cash flow value from ABD in 2 final years will reduce 20%, which means this value will multiply the 0.8, and we just have sorry, but we copy this to and then this is if so you just have this condition if so you can see this function here. If with the condition the random number from the continuous random number from 0 to 1, if we create a random number is more than 80%, the 0.8, so the number, the cash flow in year 6 will just reduce to 20%. It's just this number multiplied the 0.8. And if this logical incorrect, we just keep this number. We just keep this cash flow. Okay, and so we have the condition, the assumption in our case here with the year 5 and year 6. And when we enter, we can see the trend in those number. So I will mark a red color for all of the random number we have in this situation. Okay, and just now we just calculate the NPV again.
Teacher,
Sorry.
I can ask you a question about the if function.
Okay.
I read the title say that the cash flow is more than 80% happen. So if you use the rank number higher than 0.8, so I think it should be higher than 0.2 because it will happen 80%. But if you do that, the rank number will run between the 0 from 1. And if you choose the number is higher than 0.8, so
I got you. I got your idea. Sorry. Yes, you're right. Because I say 80% probability that the project from ABD will reduce 20% in value. So I have to correct this because that's so it's a 20%. 20%. Yes, you're right. So the random number you create, if it's more than 20%, this is 80% probability that you create a random number from 0 to 1 greater than 0.2. 0.2 is a 20%. So it's 80. It means 80%. 80% the probability, and you have the cash flow reduced 20%. Is you just take it, multiply with 0.8, and if not, is just keep the cash flow. Okay, so I know. So that is the 80% probability. That's a lot of probability which change your value of cash flow in the 2 finance years. So you just keep calculating the NPV and sum on the NPV here. And after that, you simulate 1000 NPV from this objective cell. So we have created a number and the NPV column. From the number, you just mark from 1 to 1000 using the field in the home tab. So yeah, you can use a field, and it will give you a series from 1 to 1000. Series will run from the column, and the stop value is 1000. You just click OK, and you will have the 1000 NPV, 1000 number. And NPV, you just take the NPV from our formula here. So we use the data table technique to fill every NPV with the simulation modeling from the sheet 1. First of all, you choose on of the block. So remember, when you choose on of the block, you click Control Shift and the arrow down. Control Shift and arrow down. It's marked on of the block from the first one to the last one. And you choose the data table, data what if analysis, data table. And in the column input cell, you just click any cell. We call it a dummy cell, the dummy cell. It's not a real cell. Just click any cell outside of the table, outside our table, and we press OK. What happened? Yes. And so we have 1000 MPV. We just simulate 1000 MPV in this situation. And we want to build the histogram of 1000 MPV. We use the analysis tool here. And we just choose the histogram. And you input on 1000 MPV. On 1000 MPV here, and click OK. So the histogram will transform your MPV from the lowest to the highest with the frequency of each MPV you calculated. And then you just insert the bar chart, the column chart. You can have the histogram. So as you can see, the histogram is not beautiful as the normal distribution. The normal distribution is asymmetrical in the middle, like the bell shape, and they have the highest value, high frequency in the middle. That's the mean value, And when we move out to the tail, the frequencies will reduce a lot, will decrease a lot. So this is the histogram of 1000 MPV, but we just simulate 1000 MPV, so the histogram is not good. If we have a simulated 10,000, 100,000, or 1 million times 1 million MPV, so I think the histogram is will decent and will be decent and will be beautiful, just as the density function of normal distribution. And if we want to calculate the probability which is in which the MPV will be less than 200 million, we need to find out the mean value and the standard deviation value of the 1000 MPV. So we use the average to calculate the mean value of sorry. So just press Control Shift and the arrow down. So that's it. Cover on the block. 1000 MPV. And standard deviation, we use the standard deviation dot P. P is a population and S is a sample. Just use P in every parameter function in Excel. So we have the standard deviation of 1000 MPV, and we calculate the Z score. And if we want to compare with the specific value, such as the 200 million, so our Z score will 200 minus mean and divide by standard deviation. So that is the Z score, and we just use the function norm as this to find out the probability of this Z score. But it's quite small. It's extremely small. It's quite small. Because you see the mean value is 289 approximately, and the standard deviation is quite small compared to the mean value, just 21, 22. So with the compare with the 200, you can see in this chart. Yes, you can see in this chart. So you can see here the very small value of our MPV is 229. So it's very tiny probability if the MPV below the 200. So we just adjust a little bit. We can compare with the 2080, 270 million. Just here, $270 million, the sum of MPV. So it will calculate on of this bar from here to here, on of this bar, and it's consider how much percentage of on this bar to the total of the bars, So 280, 270. Just try this. 270. So the probability is 18.7% that our MPV will less than $270 million. And you can see here this. You can see here this around this bar, and we just take on up those column, those bars, and it's about around 18%. It's around 18% compared with on up the bars. So that is the histogram chart from our NPV, our situation. Okay, Any question? So remember the tip when you create the random number, and if we have some assumption like 80% probability that our cash flow will disappear, or our cash flow will reduce to a specific number. And remember, we just use the rand function with the conditional if, and we just replicate in those assumptions in very simple function in Excel. Vậy thì trong cái chương này thì các bạn thấy là chúng ta chủ yếu chúng ta xử lý về cái quyết định đầu tư, hoạch định ngân sách vốn á. Thì cái dạng bài tập đó thì nó có thể có là một cái dạng bài tập chi tiết về dòng tiền. Chúng ta tính toán chi tiết dòng tiền, hồi nãy nhóm cũng đã thực hành một cái dạng bài tập đó rồi cho các bạn á, công ty Vinamilk á. Đó, một cái dạng bài tập chúng ta tính toán hoạch định ngân sách vốn chi tiết về dòng tiền. Và ở trong cái bài toán đó thì chúng ta sẽ xử lý một trong những cái nhân tố ngẫu nhiên, tức là có thể nó là doanh thu, có thể là số lượng hàng bán, hoặc là nó có thể là biến phí. Đó, những cái yếu tố ngẫu nhiên đó nó sẽ thay đổi và nó sẽ dẫn truyền đến cái mục tiêu cuối cùng của chúng ta, đó chính là cái NPV của dự án của chúng ta nó sẽ thay đổi. Và chúng ta mô phỏng lại cái NPV này. Mô phỏng là sao? Mô phỏng là chúng ta sẽ tạo ra hàng trăm ngàn, hàng triệu cái NPV. Và khi mà chúng ta tạo ra nhiều cái khả năng xảy ra, mô phỏng là một cái dạng phân tích tình huống, nhưng mà phân tích hàng triệu tình huống để chúng ta đưa lên một cái biểu đồ mật độ, hay là một cái biểu đồ histogram. Thì histogram chính là cái biểu đồ mật độ thôi các bạn. Đây, histogram này là nó là biểu đồ, nó là hàm mật độ á. Hàm mật độ thì thì chúng ta smooth nó này lại, chúng ta sẽ có thành cái biểu đồ phân phối chuẩn, smooth nó lại. Còn histogram thì nó là dạng những cái thanh bar, những cái column, và cái column, cái chiều cao của column nó đại diện cho cái mật độ, tức là cái tần suất xảy ra cái giá trị đó. Thì cái histogram nó thể hiện điều đó. Histogram thể hiện đó. Như vậy histogram nó chẳng khác gì cái hàm mật độ của cái phân phối của chúng ta. Histogram nó cũng như là cái hàm mật độ thôi. Và tổng cộng các cái tần suất này chính là 100% cái xác suất xảy ra. Thì như nãy thì nói các bạn, nếu mà chúng ta muốn xem xét coi với một cái giá trị nào đó thì trong cái hàm mật độ á, chúng ta tính ra một cái chỉ số gọi là quantile. Thì quantile đó chính là cái z-score hồi nãy mà chúng ta tính ra đó. Thì từ cái quantile đó chúng ta tra lên cái bảng biểu đồ mật độ. Chúng ta sẽ ra được cái xác suất của cái phần diện tích hình chuông, cái phần diện tích mà từ negative infinity nè, từ trừ vô cực cho tới cái điểm đó. Thì cái nguyên tắc tính đó nãy chúng ta cũng đã làm rồi. Chúng ta tính ra cái z, và từ cái z đó chúng ta dùng cái hàm có sẵn trong Excel là hàm norm_sdist, thì chúng ta sẽ tính ra cái diện tích từ cái trừ vô cực cho tới cái điểm value đó, cái điểm value mà chúng ta muốn so sánh, cái specific value mà chúng ta muốn so sánh đó. Thì nó tương ứng với lại cái diện tích của những cái bar này, những cái cột này trong cái biểu đồ histogram. Trong cái biểu đồ histogram, vậy thì cái biểu đồ histogram nó khá là quan trọng để chúng ta hình dung được cái phân phối, sự phân phối, cái cấu trúc phân phối của 1.000 cái NPV của chúng ta. 1.000 cái NPV của chúng ta, đơn giản vậy thôi. Và trong những cái bài toán của chúng ta đó thì đối với lại cái dạng mà đầu tư ra quyết định đầu tư như này thì cái phân phối mà nó sử dụng nhiều nhất á, phân phối nhiều nhất đó chính là phân phối đồng dạng, uniform, phân phối đồng dạng. Thì các bạn thấy là chúng ta vừa sử dụng cái phân phối đồng dạng để chúng ta xử lý hai cái giả định, hai cái assumption. Cái thứ nhất là dòng tiền của dự án C từ năm thứ 3 trở đi thì nó có dạng phân phối đồng dạng, và nó có thể ra những cái outcome. Những cái outcome đó là 50, 60, 70, 80, 90. Đó là những cái outcome đó. Và phân phối đồng dạng, tại sao cái chữ đồng dạng uniform? Phân phối đồng dạng là cái xác suất của mỗi cái outcome đó nó như nhau, và nó tương đương nhau, nó giống nhau. Đó, nó giống như chúng ta quăng cái hộp xí ngầu thì xác suất ra của mỗi trong 6 nút đó, mỗi nút thì nó giống như nhau. Thì chúng ta gọi đó là phân phối đồng dạng. Và phân phối đồng dạng nó khá là phổ biến. Đa số các cái bài toán trên thực tế chúng ta xử lý là chúng ta sử dụng phân phối đồng dạng. Những cái bài toán mà về xác suất thì chúng ta đều xử lý dạng phân phối đồng dạng. Phân phối đồng dạng thì nó có cái là liên tục và phân phối đồng dạng rời rạc. Thì chúng ta thấy là thường chúng ta xử lý là phân phối đồng dạng rời rạc. Rời rạc tức là số nguyên, và chúng ta thấy là nó chỉ nhận là 50, 60, 70, 80, 90. Thì hay nói cách khác là chúng ta dùng hàm range between từ 5 cho tới 9 thì nó sẽ ra một cái con số nguyên từ 5 cho tới 9. Chúng ta dùng hàm range between, hoặc là chúng ta có thể dùng cái hàm integer kết hợp với lại cái hàm range. Chúng ta cũng có thể tạo được con số đồng dạng, rời rạc, số đồng dạng rời rạc. Còn cái hàm range cái hàm range bản chất của nó là nó tạo ra con số liên tục từ 0 cho tới 1. 0 cho tới 1 nhưng mà nó cũng là đồng dạng, tức là mỗi lần con số này nó xảy ra, nó là cái xác suất nó sẽ là một phần từ 0 cho tới 100%. Nếu như các bạn quay cái bánh xe hồi nãy trong cái phần thuyết trình của nhóm, quay cái bánh xe thì nó có thể là chỉ bất kỳ một cái vị trí nào từ 0 cho tới 1, cho nên cái xác suất mà xảy ra ở một con số nó sẽ nằm từ 0 cho đến 100%. Như vậy chúng ta mới áp dụng cái nguyên tắc hồi nãy là 80% cái xác suất dòng tiền ở 2 năm cuối nó sẽ giảm bớt 20% giá trị. Vậy thì 80% thì chúng ta thấy là chúng ta chỉ cần dùng cái hàm range này, và những con số nào nó nhảy ra nó nhảy ra mà nó từ 20 trở lên, từ 0.2 trở lên, thì cái xác suất mà nó xảy ra những con số mà nhảy ra từ 0.2 trở lên có phải là 80% không? Đúng không? Đó. Nó giống như chúng ta quay cái bánh xe thì chúng ta thấy là chúng ta quay cái bánh xe mà từ 0.2 cho tới 1 thì nó là chiếm 80%. Còn chúng ta quay bánh xe rơi từ 0 cho tới 0.2 thì nó sẽ là 20%. Đó. Cho nên là các bạn đấy, khi mà chúng ta gặp những cái giả định như vậy, những cái giả định là bao nhiêu phần trăm xảy ra cái xác suất khiến cho cái dòng tiền hay là cái gì đó thay đổi, thì chúng ta mô phỏng như thế nào? Chúng ta cứ đơn giản chúng ta dùng hàm range thôi, và chúng ta kết hợp với lại một cái hàm điều kiện nữa, thì chúng ta có thể mô phỏng được cái giả định này một cách dễ dàng. Đó, thì qua cái ví dụ này chúng ta thấy có hai cái giả định mà thường chúng ta hay gặp trong cái việc mà tạo cái con số ngẫu nhiên khi hoạch định dự án đầu tư. Thứ nhất là sẽ cho sẵn cái dòng tiền đó tuân thủ theo cái nguyên tắc phân phối đồng dạng, và nó chạy từ con số nào nhỏ nhất cho tới con số nào lớn nhất, thì cái đó khá dễ rồi. Cái thứ hai là có thể cho là xác suất bao nhiêu phần trăm nó ảnh hưởng và bao nhiêu phần trăm nó xảy ra, thì xác suất bao nhiêu phần trăm xảy ra đó nó sẽ dẫn đến một cái kết quả gì đó, thì đề bài nó có thể linh hoạt, đúng không? Cái này dẫn đến kết quả là dòng tiền giảm bớt 20%, hay là dòng tiền tăng gấp đôi, hay là như thế nào đó, hoặc là lồng thêm một cái random number trong cái hệ quả đó nữa cũng có thể. Nhưng mà nhìn chung thì khi mà chúng ta hiểu rồi thì chúng ta xử lý nó đơn giản thôi, xử lý xử lý nó đơn giản thôi, không có gì khó. Ok. Đó. Cho nên là chúng ta hiểu cái hàm range này. Hàm range nó sẽ tạo cho chúng ta một con số ngẫu nhiên, phân phối đồng dạng liên tục. Phân phối đồng dạng liên tục từ 0 cho tới 1. Nó là phân phối đồng dạng liên tục. Mỗi số nó rút ra được, tức là tương ứng với lại cái xác suất từ 0 cho tới 100%. Thì chúng ta muốn tính một cái xác suất xảy ra quay số chẳng hạn, từ 40% trở xuống, thì chúng ta cứ dùng hàm range với hàm điều kiện là nhỏ hơn 0.4, nhỏ hơn 0.4. Range nó tạo ra con số mà nhỏ hơn 0.4 thì tương đương với cái việc mà xác suất 40% xảy ra. Đó, đơn giản như thôi. Rồi, ok, any question? Any question? Okay. If you don't have any question, we'll stop here. And remember, this content is quite important because it will be available in your exam, your term exam. So just practice again our case, our situation, to know how to handle this problem about the simulation modeling. Bạn Bùi Văn Phước hỏi gì à?
Dạ không có gì.
Ok. Okay, I will have some comments about group 4 presentation. I think they give us all the information we need to understand the simulation modeling, but somehow they cannot handle my a little bit challenge in generating the random number for probability. So your score is not as I expect. And at first of all, I have a tendency to give you 9 point, but I think I will reduce a little bit. So your score, your mark is 8.5 for group 4. The 3 members of group 4, the 8.5. Okay. Thank you for your contribution to our class. And the next session, we will deal with the simulation modeling in stock price and in portfolio investment. And then we applied the simulation in calculate the value of the option. It's a very interesting topic in the next session, but it's I think it's a little bit difficult for group 5 to prepare on those content. So if you have any question or you don't know anything, just ask me, and I will show you, and I will help you to understand all of those knowledge in the next chapter. Okay, thank you everyone. The class will stop here, and we will meet again in the next session. Thank you.
Thầy ơi, cho em hỏi.
Sao em?
Em ở group 5 thầy, thì thầy cho em hỏi là tụi em làm nội dung trong 3 chap 26, 27 với 30 thì mình có giới hạn ra có cái mục nào mà mình không cần làm không này? Tại vì em thấy có tới tầm khoảng 26 mục đó.
Thực ra trong cái chương 26 là cái chương mô phỏng về giá cổ phiếu, thì em tập trung vào em làm một cái bảng Excel về mô phỏng cụ thể hoàn chỉnh cái giá cổ phiếu thôi. Tại vì trong đó nó có từng bước á, thì nó rườm rà, nhưng mà tập trung vào xử lý, áp dụng cái hàm tạo ra cái biến ngẫu nhiên tuân theo cái phân phối log normal á, để chúng ta mô phỏng cái giá cổ phiếu. Rồi cứ hoàn thiện xong mô phỏng cái giá cổ phiếu 10 hay là 20 cái bước đi khả năng của giá cổ phiếu là ok. Đối với lại chương mô phỏng giá cổ phiếu ok. Chương 27 về đầu tư, về danh mục đầu tư, mô phỏng lại cái danh mục đầu tư mà những cái danh mục đầu tư nó có mối quan hệ với nhau. Thì trong chương 27 này, khi mà em nghiên cứu về cái mô phỏng các cái con số ngẫu nhiên, những cái biến số ngẫu nhiên mà nó có cái tương quan giữa các danh mục đầu tư, thì nó tập trung ở chỗ cái, và em chỉ cần trình bày khoảng chừng 1-2 cái ví dụ liên quan là được rồi. Và cái chương 30 nói về cái công cụ mô phỏng mà sử dụng trong định giá option, thì nó sẽ chia làm 2 phần. Phần thứ nhất là nó cũng giống như là mô phỏng giá cổ phiếu thôi, tại vì tính toán option giá cổ phiếu, thì phần thứ nhất là nó là muốn mô phỏng giá cổ phiếu, xong rồi nó chiết khấu lại cái payoff của giá cổ phiếu đó về hiện tại. Thì chúng ta sẽ có cái phương pháp thứ nhất để mô phỏng cho cái giá của option. Cái này nó cũng ngắn gọn lắm, không có gì. Cái phương pháp thứ hai để mô phỏng của option thì nó dùng cái phương pháp nhị phân. Cái nhị phân thì mỗi một cái giá của option nó có thể đi lên hoặc đi xuống, thì nó mô phỏng lại cái trạng thái lên hoặc xuống với cái xác suất xảy ra. Thì cái này em cũng trình bày nó đầy đủ. Và xong cái phần chương 30, nhìn thì nó nhiều nhưng mà ở mỗi một chương đó chúng ta chỉ cần tập trung vào cái bảng Excel cốt lõi của nó thôi, và chúng ta trình bày cái bảng Excel cốt lõi của nó, cũng giống như là cái kỹ năng mà chúng ta thiết lập cái biến số ngẫu nhiên, cái hàm ngẫu nhiên để chúng ta mô phỏng lại, và cái cơ chế để chúng ta tính toán. Gợi nhớ lại về cái lý thuyết tí xíu để cho các bạn nắm được cái cách mà vận dụng cái việc mô phỏng trong việc mà tính toán giá cổ phiếu, hay là tính toán cái giá trị của cái. Thì khi mà các em tìm hiểu mấy cái đó, thì tới cái file Excel nào mà các bạn làm mà các bạn không có rành thì các bạn có thể hỏi thầy.
Còn chap 26, chap 27 nó có liên quan nhau đến cái giá cổ phiếu, thì có cần nhắc lại ở chap 27 không thầy? Tại vì em thấy em đọc trong sách là
không
nó
cần
có nhắc lại 26.
Nếu mà chap 27 mà những cái gì mà liên quan đến giá cổ phiếu là không cần nhắc lại. Chỉ cần thực hành những cái gì mà liên quan đến nguyên một cái danh mục thôi.
Rồi, tầm 2 cổ phiếu. Cảm ơn thầy.
Ok, cảm ơn.